Once again, the class did not record for unknown technical reasons. So I'm going to give a quick short Reader's Digest version of the class so that it's there on YouTube for anyone that actually missed the class. And I'm going to start with announcements. Welcome. It's Wednesday, or correction, it's Monday, April 6th, actually my sister's birthday. So I'm going to just kind of go over announcements fairly briefly. Blackbaud, spent the weekend updating Blackbaud, check behind me. Probably spent 5 or 6 hours. I inadvertently could have missed something either through Dropbox or the multitude of emails that I receive daily. So if there's something missing or zero, just send me an email with it attached. That way I don't have to go back through a multitude of Dropbox to try to locate it. And if you just say, well, I turned that in, well, just give it to me again and I'll get it incorporated. I started rep grades last week. Each class for the week is worth 45 points for a total of 90. And check in with me once per week at office hours. I'll give you your 100 points. Section 6.2, problem set 4, which we're going to go over today using screen share. Okay, Paul, Tomlin, and Walden I'm missing. All right. Back on March 25th, there was a link to a Flexi quiz on a previous section. Mr. Walden, I'm still needing that from you. If you can take that today, because I'm getting ready to upgrade Flexi quiz on my computer, and when I do that, I'll lose all my old Flexi quizzes and I won't be there. So that needs to be done today, or it'll just continue as a 0. 6.3 from last Wednesday, I'm missing Toller, Tomlin, and Walden. Toller, Tomlin, and Walden. If you've got it, you can show me on the screen and I'll get you upgraded or get you graded. Today, we're going to cover 6.2 problem set number 4 because I feel like we didn't do it justice, and there was, looking at some of your problem sets, there was some misunderstandings I need to straighten out. 6.3 problem set number 2 from last Wednesday, we're going to go over, right? And at the end of class, I'll load up the 6.3 quiz today. It'll be due by noon tomorrow, all right? And last but not least, we're going to start and finish section 6.4 on Wednesday before the Easter break. Okay, so those are the announcements. And we had a few questions, which I addressed at the moment with the live class. And so this is today's agenda. We're going to do 6.2 problem set 4. I'll share my screen with you on that one. We're going to go over the 6 problems from last Wednesday that you were assigned to do that were kind of an extension of the 6 that we did on Wednesday. We're going to do a review for the quiz that I'll put online immediately after class today. It'll be due by noon tomorrow, which we just did, and we'll start and finish 6.4 on Wednesday. So let me share my screen to clarify. Clarify 6.2 problem set 4. Okay. All right. So here we go. And if there was, I noticed some misunderstanding or lack of understanding on this particular problem set. So if you would just take that out, and I'll give you a minute to do that. I'm going to kind of walk you back through it. So grab that from actually over a week ago. Okay. Now, in this particular problem set, we did kind of the opposite of what we've been doing. I was giving you the area slant probability under the curve, and then you were going to give me the corresponding z-score. So if you look at 1 and 2, very similar problems, all right, I give you the area to the left of the z-score, which is perfect for the way that table 3 in appendix B, or that table 3 that you have that I printed out for you, is structured. It fills from left to right. So let's just look at number 2. That 0.7673 is the shaded area, and we're looking for the z-score here just to the right of the mean, which was 0. Right. And if we go to the table and find it's in the interior part of the table, we know it's going to be on the positive side because it's to the right of the mean. And we find that particular area slant probability, and the corresponding z-score for 0.7673 is 0.73. Okay. I'm going to skip 3 and 4 and I'll come back to those. Now, if you look at the numbers 5, 6, 7, and 8, kind of the opposite of numbers 1 and 2, is I give you the area to the right of the mean, right? And then you're going to give me the corresponding z-score that's on the left of that shaded area, which is no big deal other than I really need this area to the left of the z, or this unshaded area in these four problems. So what do? We know the area under the entire normal curve is 1. So if I've got an area to the right of it, all I do is I subtract that value from 1. So let's just look at number 8. So I subtract that 0.7190 from 1, and I get 0.2810. So I know it's to the left of the mean, so I'm going to use the side of the table that has the negative z-scores because it's to the left or less than the mean. And I'm going to look for 0.2810. And when I look for that 0.2810, the corresponding z-score is negative 0.58. And 5, 6, 7, and 8 are all done exactly the same way. So take a look at your answers versus these. And if you've got any questions, I'll be glad to answer. All right. Numbers 3 and 4 are very similar and handled pretty much in the same way. All right. One side of this interior shaded area is the mean. So that's very beneficial information because we know the mean divides that standard curve right in half, with 0.5 of the data being to the left of the mean and 0.5 of the data being to the right of the mean. So if we look at, well, let's look at number 4. I gave you the shaded area of 0.0915, which I subtracted from the 0.50, which will give me this area just to the left of that Z line, or where my pointer is, right, which came out to be 0.4085. And that is the area I need because that's the way the table is structured. And if I go to the table and look for 0.4085, the corresponding z-score is at negative 0.23. Just take a look at that. Any questions, I'll be glad to answer. Now, if we flip it over to the back side, let's see here, numbers. Actually, 9, 10, 11, 12, 13, 14, I kind of have peppered you with several similar scenarios. Again, the mean is actually one side of the shaded area, so that's valuable information. And then I give you the area to the right of the mean out to a specific z point, right? So what I really need is the entire area to the left of that line that has the z below it, okay? Which is very easy to computate. If we look at number 9, we got 0.3729. All right, but I need all the area to the left going from the z back to the left. So all we do on all 6 of these problems is we add the 0.5 quadruple 0 back into the whatever value I gave you. In this case, it's 0.8729. So if I go to my table, I know it's to the right. I'm going to go to the positive side of my table. The corresponding z-score for the area 0.8729 is 1.14. Let's do 13 just to reinforce it. Same thing, the shaded area is 0.4590. I need that shaded area plus everything to the left of the mean, which is 0.5, so I add that back in. I came up with a total value of 0.9590, which is the entire area slant probability to the left of that z, and the corresponding z-score is 1.74. All right, let's see here, numbers 15, 16, 17, and 18 are all handled very similarly in kind of the converse of those 6 above it. All right, let's look at number 15, okay? So I gave you this little shaded area between the mean and the z bar right here, right? And I really need this area to the left of where that z line is, or that left edge of the shaded area. So I just subtract that 0.1844 out of 0.5, which will give me this unshaded area to the left of the z, which came out to be 0.3156. All right, go to the table, and I'm going to locate 0.3156. I know it's going to be on the negative side of my z-scores because it's less than and to the left of the mean, and the corresponding z-score is negative 0.48. And these 4 are all done identically the exact same way, just different values. So take a look at what you have. Take a look at the computations here, and I'll be glad to answer any questions. All right, none being heard. All right, I'm going to stop sharing the screen, okay? We're going to now, if you would, grab your problem set 6.3, number 2 from last Friday, or correction, last Wednesday. Time flies when you're having fun. All right, and we had 2 scenario problems. One with how much money you spend on fast food per week, and one on plumber salaries. We did 3 problems for each one of those 2 scenarios, and then I gave you 3 problems to work on over the last several days for today's assignment and to prep us for the quiz in this particular section. Okay? So I've already done this, unfortunately, but the record button did not, I did not press it hard enough, I guess. So we had a fast food scenario with the average person spending $44, or the mean being $44, and a standard deviation of $14.50, right? So we did A, B, C, and for D, you were asked to sub, what's the probability or likelihood someone spends less than $35 on fast food per week? So we just do the, how many standard deviations is $35 to the mean? So we did 35, which is our X value, minus the mean of 44 over the standard deviation of 1450. That came out to a negative 0.62. So I grab my table 3 and I come down to the negative 0.6. Down the left column, I go over to 2 hundredths across the top margin, and we come up with a value of 0.2676. And this is nice because what I'm being asked is exactly the way the table is structured. And so to convert this to a more common sense terminology, particularly if your audience isn't quite into the details that you are, this is saying that 26.8% of our population is spending less than $35 on fast food per week, 1/4. All right. Hopefully that makes sense, and you're getting into kind of a rhythm and routine of solving these. The next problem was, what's the likelihood or probability that someone spent more than $50 on fast food this past week, right? So exact same methodology you just did in the point above, right? So it's, here's our mean of 44. It's asking you to solve if you, what's the probability of spending more than $50, which is the shaded area here. So it's the X, which is 50, minus the mean of 44 over the standard deviation of 1450. That equates to 0.41. Do not abbreviate to tenths. The reason that table's got over 1,000 computations on it so that we can be fairly precise in our calculations. Don't round that off to 0.4. Come down to 0.4 on the left column, cross to 0.01 on the top margin, and you'll come up with an area or probability of 0.6591. However, that is the area to the left of the mean, and we need the area to the right. And as you know, this total area under the standard normal curve is equal to 1. So we subtract 0.6591 from 1 and get a value of 0.3409. And to put that in understandable terms, it's saying that 34.1% of the population, pretty significant, about a third are spending more than $50 per week on fast food. Okay. The last problem actually was done by design and to save you some time and work of what's the probability someone spends more than $35 but less than $50. Well, we don't need, you've already done these 2 computations here, so you don't need to repeat yourself. We're going to just take the areas that we've obtained off the table and figure that out, all right? So the 0.6591 goes all the way back to the left from that $50 value, and the 0.2676 is really this unshaded area to the left of 35. So we need to take this 2676 from the 6591. It came out to be 0.3915, and to put that in commonsensical terms, this means that 39.2% of our population is spending at least between $35 and $50 on fast food per week. Right? That's pretty significant. Almost 40% of the folks are spending between $35 and $50. That's a pretty significant part of your population. I hope that makes sense, and I'll let you look at that for a minute and compare what I have here with what you have on your worksheet in front of you, and take any questions. All right, hearing none, we'll move on. All right, so the other scenario The other scenario was the plumber's salary, and this data is kind of old because it seems kind of low to me. I think it was 2012, if I remember correctly. And the average or mean plumber salary at that time was $47,500. Okay, come in just a little bit closer, with a standard deviation of 5,250 bucks. All right. And the first question, or in C, I asked you to determine what's the probability that the person earns less than $40,000 per year. All right, so we're going to do the exact same calculations or exact same methodologies that you used over here in the fast food scenario, where we're going to subtract our X. X is 40,000, and from that, we're going to subtract the mean of 47,500. It's always X minus the mean. Otherwise, your signs are going to be reversed. Then your areas of probability is going to be reversed. You're going to end up with kind of the opposite or inverse answer. All right, it is divided over the standard deviation of 5,250. All right, we do the math. It comes out to a negative 1.43. And we go to the table. And the value is 0.0764. And we just use that value because it's asking you exactly the way the table is set out. 44 being, or 47,500 being our mean, and it's asking us for 40K. So it's asking us this, which is exactly the way the table is set up. So I don't need to do anything with this other than I converted the probability to 1%. And the next question you're asked to calculate what's the probability of earning more than $50,000 a year as a plumber. Same methodologies, the X with the mean subtracted from it divided by the standard deviation came out to be 0.48. And that value was 0.6844. I'm going to do this one in red and I want to repeat my graph. So in here, we're asking for 50K, all right? So we're asking more than 50K. So it's that area right there, right? But when I go to the table, I get 0.6844, which is always, it's all this area to the left. And I need the area to the right of that value, right? So I just subtracted from this 0.6844 from 1, and I've already converted the probability to 1%, 31.6%. Take a look at what you have and see if that agrees. All right, hearing no additional questions, the last part of this was to calculate between 40,000 and 50,000, what's the probability of someone's making between that $10,000 spread, right? If you look at my kind of rough drawing here, 44 is the mean, 40 is the low margin, 50 is the high margin. Now, we don't need to do any more math because we've already determined the areas for 40 and 50 in our previous calculations. So we're just going to subtract the smaller, which is this start area to the left of 40,000, from the larger, which is the 50,000. And I've already converted it for you to a percentage, is that 60.8% of our population, almost 2/3, fairly significant, it's going to make between those salaries of 40 and 50 grand. Take a look at your work versus this, and I'll be glad to entertain any questions. All right, hearing none, let me go ahead and recap. All right, so it's going to be X minus the mean over the standard deviation. All right, always X minus the mean. That'll give you the number of standard deviations you are from the mean. Okay, and then use your table 3 to get the area, and then you may have to do some additional math depending on if it's a less than or greater than, or it's in between two values. All right, I would strongly encourage you to draw a graph, again, because I think that kind of solidifies what you're being asked to solve. I will, after class today, post the quiz under daily assignments. I just ask that you complete it and put it back in Dropbox by no later than noon tomorrow, so I'll give you a 24-hour cycle to do it. Please do your own work, no collaborative work effort. You will need your table 3 to answer the questions. And good luck, and I will see you on Wednesday.